SciCuriousID presents. What can burn hot enough to turn solid steel into glowing liquid in seconds? Meet Thermite, a curious mix that doesn't burn like a campfire, but reacts so fiercely it can melt metal. Its violent, beautiful, and utterly fascinating nature has a rich history.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
The story begins in the late 19th century with German chemist Hans Goldschmidt, who discovered the thermite reaction, a form of aluminothermic reduction. Originally used to produce pure metals and weld iron rails without a conventional furnace, thermite became an important tool in metallurgy and industry. Over time, it found specialized uses, from field welding on railways to precision cutting, and even in certain pyrotechnic applications. But make no mistake, this is not a gentle process. So, what's actually happening on the molecular level? Thermite reactions are driven by redox chemistry, a transfer of electrons between a metal-reducing agent, commonly aluminum, and a metal oxide like iron oxide. The aluminum strips oxygen away from the oxide, forming aluminum oxide and leaving the metal in its elemental, often molten, form. This chemical dance releases enormous energy as heat, with temperatures often exceeding 2000 degrees Celsius, hot enough to melt many commonly used metals. Because the reaction is self-sustaining once started, it produces a stream of molten metal and dense, extremely hot solids called slag. Importantly, thermite reactions are energetic, localized redox events, not combustion in the normal sense. They produce little gaseous byproduct compared to fuels burning in air, but the heat and molten products are the source of their destructive power. Fun fact, thermite welding was once prized for repairing railway tracks quickly and reliably in remote locations because no external furnace was needed. Engineers could weld rails on site using specially designed molds and strict safety procedures. But here's a sober human touch. Because of its extreme heat, thermite has been misused. Its hazards include severe burns, molten metal splatter, and intense radiant heat. That's why industrial use follows strict protocols, and why demonstrations are done only by trained professionals behind shields with full protective gear. In controlled industrial settings, thermite is a powerful ally. It can produce high-purity metals, join sections of rail, or cut thick components where conventional methods are impractical. Scientists also study thermite-like processes in planetary science. Similar redox processes occur in volcanic and meteoritic events that shape planetary cores. Researchers continue to explore safer, stabilized alternatives and precision techniques to harness the heat while minimizing risk. Thermite is a spectacular example of chemistry's raw power, a reaction that literally melts our assumptions about how hot a chemical process can be. It's awe-inspiring, but also dangerous. If you're curious, watch professional demonstrations or read peer-reviewed literature and never attempt it yourself. Curious for more? Subscribe and stay curious with SciCuriousID.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.